Hey, hello. I'm glad to have you in this class, part two of oxidation numbers. In case you are here to check the part one, please search for it on our channel and watch. That is going to better your understanding of this as we talked about rules for calculating or finding oxidation numbers. So it's these rules we are going to put into practice now. Okay, so let's get down to class. Now, we are going to try to calculate this. We'll confirm number one. We want to verify that the oxidation number of a compound, okay, is equal to 0. Okay, if you have a compound water molecule, for example, and we want to find out that the oxidation number of this is equivalent to 0. Okay, so before we do that, please, I'd like you to follow this and so that you can understand it squarely. So the first thing you should note is that you must learn the default oxidation number. It's very important for you. There are some oxidation numbers of common elements, such as those ones in the periodic table, the first 20 elements. So we should be familiar with it. Hydrogen, for example, is +1. Oxygen is -2. Okay, alkali metals, such as sodium, potassium, they're +1. Alkaline earth metals like calcium, magnesium, they are +2. Halogens like chlorine, bromine, they are all -1. Okay, so please put that and learn the tricks. Okay, so the next thing you should also find out is total oxidation number of a neutral compound is always equal to 0, and that's this question we want to verify now. Okay, how is it going to be equal to 0? We'll verify that shortly. Then third things that you must also take notes is for ions. Okay, the total oxidation number will always be equal to the number of thirds of that particular ion. Okay, so we also verify that. So if you have Na plus, so it means the oxidation number of that is going to be +1. Okay, and you remember we have monoatomic ions and we also have polyatomic ions. Okay, so we'll verify that. And finally, you must use algebra. So whenever you're solving for the unknown oxidation number. So here we are. The first question that we have to solve now, we want to verify the oxidation number of a neutral compound is 0. So now we already know that oxygen is what? -2. That's why we say that learn the default. Okay, then hydrogen is +1, but we have 2 atoms of hydrogen. Each atom is +1. So what do we do? So represent, okay, the first one by +1. So since we have 2 atoms, multiply by 2. Okay, so we say use algebra. It's very important. Then plus the oxidation number of oxygen is -2, so use it also like this. So what do we have? So we are going to have +2, okay, -2. So this is equivalent to 0. So which is okay. So we are good to go, right? Good. So the next thing we are going to talk about is the next example. So let's say we want to find we want to verify also for potassium permanganate. Okay, if we don't know the oxidation number of manganese there, so it is very easy to do that also. Let's say you have your potassium permanganate, KMnO4. Okay, potassium permanganate. Yes, so if you have it this way, okay, yeah. So now we want to calculate, of course, this is so potassium is familiar. You are familiar with potassium. You are also familiar with oxygen, but you are not familiar with manganese because it's not in the first 20 elements. So, and because we are not familiar with it, we want to look for the oxidation number of that. Okay. So how do we do that? Understanding your defaults. So this one now will be equivalent to we having potassium is +1. Okay. This is +1. Okay. Manganese, that's what we don't know. Okay, that's how we say use algebra for this unknown that. So let's say we use X for that, for the one we don't know. Then plus oxygen is -2, but we have 4 atoms of oxygen, so that means we're going to have -2 times 4. Okay, -2 times 4. Okay, as simple as possible. So if that's what we have, so this is going to be +1. Okay, then plus X. Okay, then -8. Now remember that this is 1 minus 8 plus x, right? Yes. 1 minus 8 plus x. So this will be equal to minus 7 plus x. Minus 7 plus x. Minus 7, okay, plus x. Good. So now, we are here now. There's one thing I need you to understand. We already stated that the total oxidation number of any neutral compound is equivalent to 0. So this happens to be a neutral compound. So we have to equate this to be equal to 0, because that has been understood. So it means this one will be equivalent to 0. So, and if it's equivalent to 0, mathematically, we need to tell you like this. Okay, good. So this one will be equal to 0. Okay, all of them will be equal to 0, please. Okay, equal to 0. This one is equal to 0. And if that is the case, if this is equal to 0, so what we are going to get is what? We will end up having this, my x. So make x the subject of the formula. So x will now be equal to plus 7. Okay, so x is equal to plus 7. So it means the oxidation number of manganese, okay, is equal to 7. So meaning manganese, okay, has the oxidation number of plus 7. Okay. So of course, one of the advantages of oxidation number, it helps us in the nomenclature. Okay, so if I want to really pronounce or tell you the name of this potassium permanganate, I'm going to tell you that this is potassium tetraoxomanganate 7. Okay, potassium tetraoxomanganate 7. So that oxidation number of manganate is what we say manganate 7. This is question 3. We're going to dive into it quickly. We want to solve the oxidation number of sulfur in sulfate ion. So what is the oxidation number of sulfur in what? In the sulfate ion. So that's what we want to solve now. And please take note that this is an ion, okay? It's an ion. This is not, of course, it's a polyatomic ion. So I want to understand that. We already told you that for an ion, the total oxidation number, look at it here, the total oxidation number will always be equal to the number of charge of the ion. So the number of charge of this ion is -2, okay? So which means that we are going to find the individual oxidation number of the elements involved, and we equate it to -2, okay? If the compound is a neutral compound, we equate to what? 0. So that's established. So what we say is that for sulfur, which that's what we want to calculate for, we don't know yet, is represented as X. Then for oxygen, we already know that oxidation number of oxygen is -2, and we have 4 of them. So we need to multiply it by 4. Okay. Then this will be equated to -2. Okay. So I want to understand that. So this is X plus, -8. Okay. Then this will be equal to -2. Okay. So we're going to add 8 to both sides. So this is 8, -8 plus 8. Okay, so as to be able to find the value of x. This is -2, since we added 8 to both sides. So let's do that here. So this is x will be equal to, this one we cancel to become 0. So this x is equals to +6. Okay, this is +6. So it means the oxidation number of sulfur will be equal to +6. So the oxidation number of sulfur is in a sulfate ion is what? +6. So I want to believe that you've listened attentively, you've enjoyed the class. This is Smart IQ. Get to subscribe into our channel and watch all other videos, and see you in the next class.